Hello, everybody. So my name is Jennifer. I'm the CEO and the founder of a company called Alectio. We are the very first DataPrepOps company. And one question everybody has when they first hear about us is, of course, what is DataPrepOps? And so this is a question that has many different, like a variation of different answers. So today we're going to try to cover what it is, why it's important, how other companies are coming into the picture as well. And I hope you find it interesting. All right, so quick rundown of what we're going to cover today. So first and foremost, we're gonna explain a little bit where DataPrepOps stands on the market. So you'll see where other basically solutions integrate and where we can see the market grow today. Right? We're going to talk about data-centric AI because there is a very, very, very close integration of data-centric AI and its concepts into the concept of DataPrepOps. Then we'll discuss the different pieces that you would actually need if you wanted to create your own DataPrepOps workflow today. We're going to show you an example of an existing platform, which is ours, and then basically hope that you will find some inspiration for your own projects. All right, so let's start by the market. It sounds like this would be the most boring part, but I think you would actually find it relatively interesting. So before we jumped into DataPrepOps, I'm sure you have noticed that the term is similar, or basically it reminds you, of course, of MLOps, right? So before explaining what DataPrepOps is, let's talk about what MLOps is, right? So for me, the history of MLOps starts about 10 years ago when companies realized they wanted to invest more in machine learning because they started to have the capability of collecting lots of data, and they started hiring data scientists to build models, right? The problem is very quickly, even though those data scientists were doing an excellent job at creating models, most of the time they had no idea how to push something to production. And so the very first MLOps companies basically were born out of that necessity of assisting companies and data scientists in transporting and deploying a machine learning model that existed on a data scientist computer all the way to production, right? And then little by little, the market also realized that there were lots of other opportunities to make it a lot easier to build a machine learning model. So we started seeing different flavors of company that would also assist for the tuning of a deep learning model, or hyperparameter optimization for a deep learning model, or companies or solutions that would provide ways for basically decide which architecture, which type of algorithm we wanted to use. Some started providing versioning, different tools for visualization of the performance of the model and whatnot, right? Without going as far as to say that today, MLOps is the one solution that gives you a low-code solution or no-code solution for machine learning. It is definitely a lot easier for both companies and machine learning scientists to basically get started with modeling and take care of modeling, right? So this is basically where MLOps stands, right? I mean, so basically a few years back, you had this huge gap where lots of companies were very frustrated when they were injecting a lot of money in machine learning, and basically that was not providing a return on investment, right? And ever since then, I think it's fair to say that the market has matured significantly. There are plenty of solutions out there. Not all of them does everything. I think we can anticipate some consolidation on the market as well, right? But companies are still frustrated. And so at that point, they are mostly frustrated because they're already in production, they're working at scale, and still something's got to give because machine learning is still very expensive. Today, with the adoption of large language models, it's getting worse because people who want to tune those models or make them retrain them on domain-specific data or whatnot, they all realize this is incredibly expensive. Why is it expensive? Because the next barrier to entry and the biggest barrier to entry and to return on investment essentially comes from the cost associated to the volume of data. So both data preparation and basically like the compute that's associated with working with large data sets, right? So this is where DataPrepOps is entering the game, right? I mean, so we basically talk about this problem of like return on investment and dramatic challenges associated to large data sets as the AI cost chasm. And basically DataPrepOps is supposed to be whatever MLOps was for the creation of a machine learning model, it's supposed to be for the data preparation of a data set for machine learning. So this is at a high level where DataPrepOps is. It's actually one of the reasons why you see this is coming into the game a little bit later, because for the longest time we have been focusing mostly on model preparation, right? So before talking in more details about DataPrepOps, let's talk about data preparation, right? I mean, so data preparation is an interesting concept because most likely you associate data preparation for machine learning to data labeling. And so this comes from, this perception, generally speaking, comes from the fact that many data labeling companies tend to market themselves as data preparation company, which they are. But oftentimes people tend to forget that in order to turn a raw data set into something that can be used as a training data set in a machine learning model, well, usually there's lots of steps involved in this, right? I mean, so this is kind of this slide should give you some kind of reminder of like everything that's associated to it, right? I mean, so you have to think about like removing potential harmful outliers. You have to think about quality. You have to think about operational constraints, how the data is organized. You have to think about privacy, data collection, or whatnot. All of this falls under data preparation. So data preparation is no way as simple. And I'm not saying that data labeling is simple, but it's no way restricted, limited to the concept of data labeling. So if you want to sort of understand like where you would need a DataPrepOps solution and where it would fit with the other elements you have in your current ecosystem, right? So basically like go back to that conversation we just had about MLOps, right? I mean, so basically like you have like a relatively mature MLOps space that's maturing by the day, where you have all of these amazing solutions that help you like create the best model possible, potentially like you reuse existing models, give you solutions to transfer learn or whatnot, right? And this is really like taking care of like all the different elements of model preparation. So model preparation has become a lot easier, and you have lots of options out there that you can purchase, you can use. You have open source solution that you can use as well, right? On the other end of the spectrum, right? People have the perception that basically like the data, the taking care of the data is also like relatively streamlined, because we have all great solutions for data engineering. We have like a Snowflake, Databricks, like we have all of this, like a data lake, data mesh solution out there. You have like the big cloud providers providing you solutions where you can organize, you can store securely all of your data, right? But then you have this huge gap in the middle that basically like consists in converting your raw data set into something that can be consumed as a training data set in a machine learning model, right? And all of this normally is done more or less by hand, right? I mean, so if you were in that situation where you have this huge like image data set that just comes in raw from the output of a camera or a camera stream somewhere, right? I mean, let's assume like a case of autonomous driving, right? That wouldn't be what you would directly feed into your model. Instead, you would have to make sure that there is no duplication in that data. You would have to sure that none of that data is corrupted. You would have to do a lot of cleaning. You would have to do a lot of quality management. You would have to annotate that data, validate the annotations or whatnot. And this is usually where data scientists today spend most of their time. And that's because there is no way to like facilitate, automate, or put that process on autopilot, right? So the dream and the target of DataPrepOps is exactly that. It's like bridging the data ops space, those solutions that you have to store your data, and the ML ops space, where it's all about, like a high performance machine learning models. Right? And so we'll talk a little bit later why it doesn't really fit in either of the boxes, because DataPrepOps is, like bringing a new paradigm where you can actually prepare your data at the same time as you train your machine learning model. So it's actually like a different category compared to DataOps, right? Okay, so let's talk about like a more technical kind of things, right? So I'm sure you've heard the concept of data-centric AI, right? Data-centric AI is a concept that became popular about 2 years ago, right? I mean, which is basically like a type of machine learning approach where instead of putting all of your focus on the model, you're going to put more focus on the data, right? So just to explain a little bit like what I mean exactly about this, right? Your traditional machine learning training approach, supervised learning approach, would consist in sourcing some data, preparing the data. So you would take like whatever time is necessary for this to make sure the data is in the right form, that the annotations are proper, whatnot. And this is sort of like the bottleneck for everything else in the process, right? Once you get that data, you consider that training data static, and then you're going to feed that data in your model. And then the rest is history, right? I mean, I think anyone who's trained a machine learning model knows that you're going to train, you're going to run your validation process on top of this. You're going to decide whether or not the results and the performance of the model is good, are good enough for you. If they are not, you go back to the drawing board, you make changes to the model, not to the data, and you keep going until you're sufficiently confident that your validation results are where they need to be before you move on to the test phase. And basically, like at that point, you would decide to deploy the model. That's the traditional way of doing things in a supervised machine learning way, right? So data-centric AI is sort of like, I'm not going to say the opposite, but like it takes like a different like iteration process, right? So just the same way, of course, you need some data to get started, right? I mean, so you would still like source some data, you would prepare that data in a first like version or whatnot, right? And then you would try to like train your machine learning model with it, right? But then if you are not happy with the results, if you feel like, okay, my model needs improvement, instead of taking action on the model, you're going to take action on the data itself, right? I mean, so at this point, the data-centric AI paradigm is going to tell you like, I'm going to improve my annotations, I'm going to add more data, I'm going to do all of sorts of things to try to tune the data as opposed to tuning the model, right? And this is a popular, like this was actually like a conversation that was going on for a couple of years among experts, because it's been years people realize that oftentimes you get a better or a much more substantial improvement by improving the data than improving the model. So this is sort of the materialization of that thought. So when people first like hear about data-centric AI, or even like a lot of what you can read about it on the web is related to either the concept of data labeling or the concept of active learning, right? The reality is there are lots of flavors of data-centric AI, right? So basically, like you will have the case where, like a kind of like the same workflow I explained. When you reach that step where you want to touch to the data to improve the performance of your results, you can select records out of a batch that already exists. This is exactly what active learning is about. You can actually decide to go source more data, which could be like by generating more data or by collecting more data, right? And so you could do that in a clever way where you have like a information that comes out of the model to guide you into what needs to be done, right? You could actually decide to augment the data or just fractions of the data. So apply data augmentations of all sorts, right? One challenge here being like, which ones should you basically apply, right? You could also decide to change the labels, improve the labels. This is what you would call human in the loop data labeling, right? I mean, so you could realize that there were some issues with the quality of your labels and address that dynamically, right? In fact, you can even remove records. People don't necessarily think about this, but there is a concept known as catastrophic forgetting, which essentially means that you will basically like have a problem with the model forgetting some of the information that was already absorbed, right? So there is actually no reason why you couldn't use a data-centric AI approach to actually take away some of the records that you feel have been hurtful, harmful, or problematic to the model. So this is, in a nutshell, what data-centric AI is. Why is this important for the rest of the conversation? Well, you can also treat DataPrepOps as MLOps for data-centric AI in many ways, right? I mean, so basically, like it's really the same shift, like the same like a shift in paradigm that you see like between model-centric AI and data-centric AI is the same shift that you see between MLOps and DataPrepOps. So, all right, so we talked about active learning. Active learning is very, very, talked about in the context of data-centric AI, right? I like to talk about data curation rather than active learning because there are many different ways to curate a data set, most of which include like more advanced solution than just active learning. But let's talk about active learning for a second. Right? So active learning, basically, like first and foremost, I would say, forget what you've heard about. Like active learning has nothing to do with human in the loop data labeling. So it's actually like it's a incremental, semi-supervised approach that allows you to pick records on the fly and decide which ones to annotate. In practice, you don't need a human to be in charge of the annotation, which is why it's not necessarily a human in the loop approach in this case, right? And so this picture, like this slide, should give you an idea of like the overall process, right? I mean, so the idea behind active learning is basically like you start with a raw data set, right? I mean, so that can actually be that data set that sits in your data store somewhere, right? Doesn't need to be prepared, doesn't need to be annotated and whatnot, right? Originally, active learning was developed to help people decide which data to annotate, but it doesn't actually help you generate the annotation, right? And so what happens with active learning is like, you have, let's say, 100,000 pictures, raw pictures. You're going to take a small batch of that data, at first randomly. You're going to annotate that data, and then you're going to use that data as your training set. And so basically, like by doing that, you're actually growing your training data set, right? And then the trick is that the model, in whatever state it is right now, you're going to apply on the rest of your unlabeled pool, right? I mean, so if you had 100,000 pictures, you annotated only 1,000, and you use that 1,000 to train the model, you have 99,000 records you still need to pick from. And basically, like, so you will run inference on this to try to identify what is most likely to be informative to the model at the next stop. So this is all active learning is, right? How you make that decision is really up to you. There are like querying strategies which can change depending on your use case. You actually tune and decide what this logic, this querying strategy actually is. So sort of like a repeat of what I just said, right? I mean, so it's really like active learning is like, and it fits very well with the data-centric AI approach, right? I mean, so it's all about like selecting some data, labeling some data, training your model with this data. The typical trick in active learning is like that model in this current state, you apply on the rest of the data. And then you can use an approach like what we call the least confidence querying strategy, which is to say the predictions that came or with the lowest confidence score should be picked because you want to correlate the fact the model struggled or is not sure that it made the right decisions as a sign that it would be useful for the model to be exposed to that data as part of the training data set. So this is basically the workflow of active learning, right? So there are like many things you actually need to think about if you want to do active learning, right? I mean, so you need to think about this logic of how do I decide which data to pick next, right? I mean, so in fact, in practice, this can be a full machine learning model. This is basically what Alectio does, right? Then you have to label whichever data that was selected, right? But the problem here is since you're training the model incrementally, you better have a real-time labeling process as well. And that's not something that your vanilla labeling company is going to be able to support. Right? Then you train, right? I mean, so guess what? Like we're in this case, like we're very well equipped on the market that there are lots of solutions for the training of a machine learning model, and then the inference is something that's relatively well understood as well. This means that so the workflow is relatively complicated because it's iterative. It requires versioning in lots of places. It means keeping track of the state of the model and things like this. So, all right. So in order to clarify one more time that basically what you understand as human in the loop labeling is different from active learning, I just made that quick picture for basically as an explanation, right? I mean, so the workflow I just presented where you use active learning to select data basically involves a double loop, right? I mean, because you have the main loop that actually decides which data you dynamically select, right? You could use the same problem to decide which data to add, either synthesize or select, right? And then whatever data is selected, you need to annotate. But then when you annotate, you might want to iterate a couple of times to get it right? I mean, so this is what human in the loop labeling is, right? I mean, so it means like for the same specific batch of data that you selected, you want to keep going and validate your labels and run anomaly detection if you need to basically proceed, right? But there is actually like two separate workflows and two different loops happening in the system, right? So this is why your traditional workflow for supervised learning and a traditional MLOps platform is not going to be well suited to support that kind of use case, right? So why would you want to do this? Why would we don't want to curate data, right? I mean, so the original active learning was based on basically like the goal was to save on data labeling. That's why it was invented in the first place. Now, if you do it right, you can also hope to save on computational resources, paradoxically, because you would feel you would use more compute by retraining the model. But if you can get to a consensus quickly, you would actually also save on compute, right? Generally speaking, you want to save on operational cost. You can sometimes and oftentimes actually reduce training time because you don't need to go through the entire data set. But then the side of the active learning few people know is that you can actually boost model performance. So by using less data, you would get a better model. Who doesn't want that, right? You can diagnose problems with your model. In fact, you can even explain the model because you know which part of the data was useful, and that gives visibility in terms of how the information gets transferred from the data into the model, right? So before we jump in the end-to-end, like basically like a engineering part and pipeline part of the conversation, right? We talked about like the necessity for an active learning process to have like real-time labeling capabilities. Because if you have 50 loops, at each loop you select some data, you cannot afford to wait like days, weeks, or months to basically have that data annotated, right? I mean, so the workflows with which like labeling companies usually like provide their services just doesn't work, right? I mean, so you need like real-time or quasi-real-time labeling. Auto-labeling is an approach, but you don't need to use auto-labeling. You can, what you actually need is like a way that you can trust even human annotators on the other side to jump on your task and take care of it. This can work really well because you work with much smaller sizes of data set, number one, because you're curating. Number two, because this is like you're looping. So basically like you're just sending a fraction of the data every single time, right? But you also need transparency, right? I mean, so basically like you could easily like break the bank if you didn't know how much it would cost, right? You need workflows, versioning, which we just discussed, right? You need like resource allocation. So basically you need to be able to find who is available to annotate your records in real time. You need flexibility. So you need like basically like it needs to be available for you whenever you need it, right? And on top of this, you need an automated, like real-time way to make sure the results you're getting are valid, trustworthy, because if you inject the wrong labels in your active learning process, everything goes wrong. Okay? So sounds like a lot, but so basically like, so there's a lot of work to be done, right? I mean, basically like, but this is basically like the version of our platform, which basically does all of the things that I explained earlier, right? I mean, so basically the way that the Alectio system works, and I'm not saying it's the only way that you could do this, but it's certainly one way that's fully functional and takes care like of all the potential problems, right? So you would still like host your model, you host your data actually pretty much anywhere. Then we have like basically like a system of an SDK where we can listen to what's happening following that workflow of like select, label, train, infer. We can grab like basically like data that allows us to like see what happened to actually make decisions about which data should be selected. So you can do that with a vanilla active learning approach, or you can do something more sophisticated. Like in our case, the querying strategies are actually full-fledged machine learning models that can make that decision. Then the user, because you're entering that second loop, the user is going to decide like, this is, my constraints in terms of data labeling. This is the money I can inject. This is the time I have. Given like their criteria, basically we have a system for sending like data to the right process, which can be an auto labeling process or can be a labeling company. We have a full labeling marketplace. So basically we check who's available in real time. We make sure the results come back in time, right? Then when the results come back, as I said, like basically like you might need several iterations to make sure the annotations are correct. So we have like a secondary processes to check for potential anomalies, to check like for issues with the model or whatnot, right? If something looks wrong, we can send it back. You can send it back. You can choose to annotate, re-annotate yourself. So this piece is actually like a machine in the loop or a human in the loop kind of piece, right? Once everything is done, like basically like we version everything, so you know exactly like what version of the data was used when, right? I mean, so beyond which data was selected, we also are able to say like like which version of the annotations, who generated the annotation, so that you can take further action, use the same labeling company if you were happy or whatnot, right? And then the labels that were generated go back into the system, and basically you can resume your training process with the data that was selected and the labels you just generated, and you keep going until you're happy with the results. So this gives you an end-to-end, basically, DataPrepOps pipeline or MLOps pipeline for data-centric AI. So that's what it is, right? So basically, like, what we cover today, right? I mean, so it's a very nascent space. So there's a ton more to do. So basically, the workflow I covered doesn't explain how you would pick the right augmentations. Like there is a concept known as guided synthetic data generation, which is basically like signaling what data you want to generate, which is a very suitable with like a regular synthetic data generation process, right? There are lots of improvement to be done everywhere, right? And so this is like really the first version of what this should be and what this can be, right? Many of the building blocks, luckily, are already there because, like, for example, we use like regular like data orchestration technologies. We're using Flight. We used to use Airflow, whatnot. So the data engineering solution that exists for MLOps are very reusable, I would say, for DataPrepOps as well. And it's really all about like making it easy to connect, right? I mean, we're making a conscious effort that you can connect like different APIs to make it super easy. If you wanted to use like your own labeling process, your own labeling tools or whatnot, right? I mean, so just like in the case of MLOps, like it's really about flexibility, functionality, and ease of use, generally speaking. All right. So my other comment would be like, so we need more help in that space because a lot of the talent in MLOps engineering is obviously focused on MLOps tools, right? But we're reaching the point where this is really the bottleneck in machine learning, right? I mean, we need better solutions to facilitate and speed up and practically automate the step of data preparation, not just of data labeling, right? And so and one thing that's going to help is basically like what I call the right narrative for DataPrepOps is basically like we also need to shift our mindset that larger data sets are basically the solution, right? I mean, so at that point, it's not so much about how much data you have anymore. It's about processing the data the right way, selecting the right data and whatnot. So, all right. So I hope you found this interesting. So if you're interested in the topic, feel to reach out to me, feel to follow us on social media, go on our sign up for our newsletter, or we can talk. All right. Thanks to everybody.